In this video, we're going to take a look at how to name chemical compounds, whether it's a covalent compound, which is also called molecular, or an ionic compound, which is when you have two opposite charges coming together. You always ask yourself the same general questions. The first thing you want to find out is, does the compound contain two nonmetals, or is it one metal and one nonmetal? Some other things to look at is maybe it has more than two elements. That means it would be polyatomic. Or if it starts with hydrogen, then it's an acid. And then the last part down there says, does the metal in the compound have multiple charges? And I'll show you some examples of that when we get to it. So each of these questions are yes or no questions when you look at the compound. So the first example we're going to look at is, what if the compound contains two nonmetals? So if the compound contains two nonmetals, the very first thing you do is you name the first nonmetal normal, and you change the second nonmetal's ending to IDE, and then you add a prefix to each element's name. The one thing you don't do though is you don't add mono for the first element. And let's look at a few examples of these. Oh, there's your prefixes. Awesome. So you don't have to memorize those, just use the table. So if we look at CO2, we would name the first metal normal, change the second metal's ending to IDE, and add the prefix. So we get carbon dioxide. The next one, CO, we would get carbon monoxide. And again, if you look at step 4, we don't use mono for the first element. So it's not monocarbon monoxide. If we look at CCl4, then we get carbon tetrachloride. If we get P2O5, it would be diphosphorus pentoxide. And the last example, S3N2, is trisulfur dinitride. And again, all of these have the one thing in common, that they only contain two nonmetals. So when you see two nonmetals, think prefixes. Now what happens if you have one nonmetal and one metal? Then you're going to have to do some different things. So let's look at this type. When you have one metal and one nonmetal, there's 3 steps to doing this type. You would name the metal normal, just like you did in the other one. You would change the nonmetal's ending to IDE, and then you check to make sure that the metal does not have multiple charges. What I mean by multiple charges is, if you look at this table here, which I'll provide to you, is there are 9 elements that can have more than one charge to it. Now for all of these examples right now, they're not going to have multiple charges, because I'll explain those a little bit later on in the video. But you always want to check. So if we look at sodium chloride, we look at our table, sodium's not on it, so it's just sodium chloride. These simple ionic compounds don't have prefixes like the two nonmetals would. If we look at MgO, and again, none of these will have multiple charges for this step. You get magnesium oxide, CaBr2, carbon bromide, Ag2S, silver sulfide, and LiBr is lithium bromide. So if you look at all of those examples, you should see something in common. You should see that the first element, the name is just whatever it says on the periodic table. And then the second element, the ending is IDE. So ionic ones are fairly simple. The third type we're going to look at is, what if the compound contains more than two elements? If it contains more than two elements, then we know that it has a polyatomic ion. There's 3 steps when you go about naming these ones. 99% of the time, the compound will start with a positively charged metal, and you name that metal normal. Remember, metals are on the left side of the periodic table, and when they go through ionization, they lose their electrons, which have a negative charge, so they are left with an overall positive charge. If the compound starts with ammonium, NH4+, you just use the name ammonium. That's the only time it wouldn't be a metal. That's the 1% of the time. And I'll show you an example of that. The good thing about this is I also give you a chart for the polyatomic ion, so you just have to read that chart. So for example, this is the chart that you have in your paper. Barium we would name normal, and SO3, when we find it, is sulfite. So we don't change the ending to IDE, we just read the table, so we get barium sulfite. If we look at this one, you name the first name normal, which is lithium, and you look for PO4, which is phosphate. So the answer is lithium phosphate. At any time in this video, you can pause it and see if you can get it correct before you hear me tell you the answer. Here's KCN, so the first one is potassium, and the CN is cyanide. If we look at a couple more, we have CaNO3, calcium, the NO3 is nitrate, calcium nitrate. If we look at this one, it doesn't start with a metal, it actually starts with ammonium, and then the second one is hydroxide. So your answer is just ammonium hydroxide. That's the only example when it wouldn't be a metal from the periodic table. One thing I want to point out too, you can see in the second example with lithium phosphate, sometimes parentheses will be around the polyatomic ion and sometimes it will not. That's where you just have to remember that the first element is the metal and everything else is your polyatomic ion. And the more you use these, the more you practice them, it'll make sense. But I always start my parentheses after the first element if it doesn't give you the polyatomic ion. Going back and looking at the rules again, 99% of the time it'll start with a metal. The other 1% it'll start with ammonium. And you know that it's polyatomic because there's more than two elements. So now we can talk about that type that we skipped earlier on. What happens if you have a nonmetal and one of them has a multiple charge? If you have a nonmetal and one of them has a multiple charge on that table that I showed you, and I'll pull up again in a minute, then you name the metal normally. You change the nonmetals ending to IDE, so that's the same steps we've been doing. But we have the 1 and the 2 asterisks down here. When the metal has multiple charges, then a Roman numeral depicts the charge, and depicts means it shows the charge. The positive charges of the cation and the negative charges of the anion must balance out. And I'll show you some examples of these. So here's the table that you get to use of the 9 elements that can have multiple charges. The first example is FeO. Right, so you already know from naming before it would be iron oxide, but we have to do a little bit more to determine what form of iron. If we look in the middle column, we see that iron can have a 2+ or a 3+ charge. When we break this apart and we look at the ionization numbers, oxygen has a 2- ionization number because it's in group 6 of the periodic table. It would gain 2 electrons and it would have a 2- charge. And I always write the Fe, or the first one, with a question mark. So the one we would have to use is 2+, because the 2+ balances out the 2-. So it's iron 2 oxide. If we look at another example here, Fe2O3, we do the same thing where we break it apart, but this time you'll see that there's more than one atom, and that's what's in the parentheses. So for example, O oxygen still has an oxidation number of 2-, but there's 3 of them, so 2 times 3 is 6. So we have a 6- charge for the oxygen, and we need to get a 6+ charge to balance it out. Therefore, we would use the iron 3+, and it would be iron 3 oxide. So whenever you see the compound, if you know it's a multiple charge, split it apart and figure out what you need to make it equal 0. CuOH. This ties in polyatomic ions again, so you'll have to look that up. But OH is a 1- when you look it up. So the opposite of 1- is 1+. and we would use copper 1 hydroxide. Remember, the Roman numeral equals the charge. CuOH2, it's similar to the one before, but this time we have two of the elements, or two of the polyatomic ions. So we have a 2- charge for our anion. We would need a 2+ charge, which is copper 2 hydroxide. So these are pretty easy when you do a few of them, but if you don't practice them, you won't be very good at it. Here is PbO2. Oxygen is in group 6, so it has a 2- charge. You have two of them, so it would be a 4+ is what would balance it, and you get lead 4 oxide. And then the last example is CrNO3 This polyatomic ion does have parentheses. NO3, when you look it up, you would see it has a 1- charge, but you have three of them altogether. So you need the opposite of 3-, which is 3+, and the answer is chromium 3 nitrite, because NO3 is nitrite. If we go back and look at the steps again, what we talked about is when we have one metal and one nonmetal, and your metal has multiple charges by looking at the table. If you look at down at the bottom, you can see how the first one has the question marks. You're always trying to figure out what the positive charge is. And on to the last step. The last step is, what if the compound starts with hydrogen? If the compound starts with hydrogen, then you name the compound following the same rules of ionic naming. So you would name the positively charged metal hydrogen, because it starts with hydrogen, and then you change the nonmetals ending to IDE. If the compound's polyatomic, then use the name from the chart. So those are the rules that we've already practiced. And then you need to change the name according to these acid naming rules. Your ending is going to be one of three types. The ending is going to be IDE, ITE, or ATE. And you can use this table as well. It's in your packet. So start off by naming it normal. HCl is hydrogen chloride. That's how you would name it ionically. But the new form, because it's IDE, is hydro with the root word ic acid. And we're talking about chloride, so it's hydrochloric acid. If we look at the next type, HNO3, this is hydrogen nitrate. So when we have hydrogen nitrate, it ends in an ATE. So with the ATE, it changes the ending to ic acid, and this would be nitric acid. Another one that starts with an H is HSO3. It's hydrogen sulfite, so it ends in an ITE. So you would do root word, change the ending to OUS. In this example would be sulfurous acid. HSO4. SO4 is sulfate, so it ends in ATE. So we change the ending to ic, and this would be sulfuric acid. So the acid ones are pretty easy. What I always do is, when I start to look at it, does it have an H? Is it two nonmetals? And is it polyatomic? And lastly, make sure you check the metal to see if it has multiple charges. Now that we went through lots of different examples of how to do each type, and you can use your packet for the naming things, I need you to go on Quizlet and practice quite a few of these. I have the link on this PowerPoint, and I'll show you what it looks like. But all you have to do is, this is naming compounds part 3, contains all of them. So calcium fluoride, for example, NaNO3, sodium nitrate, so on and so forth. So practice, do your best, and if you have any questions, come see me, and we will get everything worked out.